Hello friends, MoNaCo here, our second video lecture in our Redox unit. We're talking about oxidation numbers in this unit, in this video. So we're going to determine the oxidation number on elements within a chemical compound using a charge cancellation technique that is review back to chemical bonding at the beginning of the year. So remember how to determine a chemical formula from the charge cancellation technique? So we learned how to find the chemical formula of compounds based on their oxidation numbers. This lecture is a review of this topic in relation to oxidation and reduction because those oxidation numbers are so important. For example, at the beginning of the year, I might have pulled out an element on the periodic table and says, okay, calcium. What's the formula if I mix calcium with bromine? And the students, you, would have to look on the periodic table and say, oh, calcium forms a +2 ion, and bromine, well, it forms many, but the most common is a -1. And so then we would do this crossing down technique to figure out what the formula was. But what we really want to do is we want to add the oxidation states up to equal 0. So +2 and -1, that doesn't equal 0 yet. So we have to think, okay, what do I got to do? I can only add more atoms, so I add another bromine with a -1 charge on it. So +2 plus -1 twice equals 0. And our formula then would become CaBr2. We don't write CaBrBr because that's just, you're doing a lot, too much. So that's why we use the subscripts to show that there's 2 Brs in this situation. So we're going to be talking about how to find out the oxidation numbers based upon the formulas this time. So we took the formula to find the oxidation. Now we're kind of going backwards in this particular lecture. So the first thing you got to know is about the rules. Uncombined elements, those are the elements not bonded to another one, have an oxidation number of 0. So if you see just lithium hanging by itself in a formula, its oxidation state is 0. Ag, 0. If it's not with another element, its oxidation state is 0. So examples: aluminum solid, sodium solid, chlorine gas, and hydrogen gas. Remember, these are those diatomic 7s, the Hofbrinkels. Those are considered pure elements, even though there's packages of 2 in that particular example. So in compounds, the sum of the charges for all the elements must equal 0, add up to 0. So for example, in sodium chloride, we have 1 sodium, which has a +1 charge. We looked it up on the periodic table, and you will need a periodic table to do this. So 1 times +1 is +1. There's got 1 chlorine there. Its charge is -1 off the periodic table. So +1 and -1, you multiply, cross multiplication there, and we get a 0. That's good. So let me get my periodic table here so we can do some more. Mg3 and 2. Well, for Mg, I've got 3 of them. And I got to multiply by its oxidation state, which is +2 off the periodic table. So 3 times +2 is +6. And nitrogen, well, I've got 2 of those. And nitrogen's got a few options. So I got to pick the option that gets me to a -6 because I got to have 0 here. So 2 times something is a -6. Actually, the first option for nitrogen is a -3. So I'm going to stick with that one. Okay, so remember, we're always trying to get to 0. So this is kind of some reverse algebra without any x's. This is algebra without x's, people. There we go. So let's check out this next one. We do HNO3. H, we got 1 hydrogen times hydrogen's oxidation state 99% of the time is +1. I know it says that there's 2 options up there, but we're really going to just go with +1 most of the time. Nitrogen, I got 1 nitrogen. Most of the time it's -3. Let's make sure that this works out. So we got a -3, and we got oxygen. We got 3 of these. Oxygen's always -2. Uh-oh. So this is a scenario where we have to kind of backtrack and think. Oxygen's always -2. Hydrogen's always +1. 3 times -2 is -6. And so we got to figure out what nitrogen's going to be if we add everything up to 0. Right now, a -6 plus a +1 is a -5. So we got to put a +5. We need this to be +5. So can nitrogen do +5? We're checking our periodic table, and yes, it can. As a matter of fact, nitrogen seems to be the most flexible element out there. It has 3, 6, 7, 8 possible oxidation states. So when in doubt, check nitrogen out. So when in doubt, check nitrogen out. So oxygen's always going to be -2. Hydrogen most of the time is going to be +1. Nitrogen might be something else in the middle. So let's do some practice and get some more of these out. The oxidation number is the number inside the parentheses. It's the charge on one atom of that particular element. Remember that most always we write the positive element first and the negative element last. This is, again, review back to chemical bonding. You can keep polyatomic ions together and use the charge from table E to determine the oxidation numbers for those elements. That's a trick. So for example, HCl. Let's do HCl. We have an H. We got 1 times a +1 equals +1. We got the Cl. We got 1 times a -1 equals a -1. We add those up to 0. We know that H has got to be a +1 and Cl has got to be a -1. Now, there's an exception to this rule on hydrogen. We do the nitrogen part of things. We got 1 of them. And we got the H side of things. We got 3 of them. Well, nitrogen being written first is going to have a +3 charge. This is the exception to the rule. So memorize this exception and nothing else. Hydrogen in this case is going to be that -1. So when you add this up, you get to 0. So in nitrogen or in ammonia, nitrogen's a +3 and hydrogen's a -1. That's the one exception to the rule that you have to know about. Let's see here. Group 1 metals always have a +1, and group 2 metals always have a +2. Within a compound, an oxidation number. Let's see, examples, lithium, chlorine, and magnesium we're going to do. So example for lithium, lithium's group 1, so it's always a +1. Magnesium's group 2, so it's always a +2. Makes your job a little bit easier when you're figuring out the other one. A +1 and a -1 have to be the case. Now, since this is 2 of them, -1 times 2, remember we do Mg, we got 1 times +2 equals +2. And we got Cl, we got 2 of them times -1 equals -2. That's how we know we got our formula right. And lithium chloride is kind of obvious because it's a 1-to-1 ratio. Fluorine always is a -1 in compounds. The other halogens, except chlorine, bromine, and iodine, are also -1, as long as they are the most electronegative element in the compound. So hydrogen and fluorine. So if they just said fluorine's -1 all the time, so hydrogen must be a +1. Simple enough. Chlorine, well, calcium's a +2 group. It's group 2, so it's +2. Chlorine, there's 2 of them, so each one's got to be -1. Sodium's +1, always because it's group 1, which makes bromine have to be -1. So there's a little bit of mental algebra going on here, because remember, we want everything to add up to 0. This one doesn't look like it adds up to 0, but that's because you got to multiply the -2 times the 1. So remember, Ca, we got 1 of them times +2, that's +2. And we got chlorine, we got 2 of them times -1, that's -2. So that's why we added that one up to 0, even though I only wrote the -1 above the chlorine. Other rules with oxidation state. Hydrogen is a +1 in compounds unless it's combined with a group 1 or group 2 metal, in which case it is a -1. So that nitrogen also was another exception to that particular rule. Hydrogen always +1 when it comes first. But if it comes second, it's a -1. Those are very kind of rare rules, so just make sure you got it in your notes so you can study that. 6th rule, oxygen is usually -2 in compounds. If you look on our periodic tables, oxygen only has one option, so not just usually, we're going to say always. Except there's always an exception to the rules with peroxides. But if we're doing this one, we got hydrogen, we got 2 times +1 equals +2, which makes the oxygen, we got 1 times the -2 equals -2. We add to 0, we know that we've got our result correct. When combined with fluorine, which is more electronegative, oxygen is +2. You're not going to see that very often. Fluorine's always -1 because there's 1 times something. And then fluorine, as we mentioned before, there's 2 of them in this case. Sorry. There's 2 of them in this case, and it's always a -1, so it's -2. We got to find out 1 times something It's got to be the opposite of -2. That's why oxygen has a +2 in this case. An odd exception that you're not going to see on our quizzes or tests, I can guarantee you that. When in a peroxide, oxygen is a -1. A peroxide is a compound that has a formula of X2O2. Also, if you look at reference table E, peroxide is a polyatomic ion. So these are exceptions for oxygen's rules that we don't really run into too often. So in this case, if we're doing Na, we know we got 2 of them, and it's always a +1 for Na, so that's a +2. And oxygen, we got 2 of them. We're trying to figure out what it must be, and it's got to add up to a -2. So that's why in this case, oxygen's a -1. H2O2, this is hydrogen peroxide. It's a disinfectant. We got 2 of them. Hydrogen's always +1 if it's listed first, so that's a +2. And then we got the oxygen, 2 of them times something equals a -2. That's why in this scenario, oxygen had to be a -1. And again, these are the exceptions, so don't worry about them too much. Overall, the sum of the oxygen numbers in a polyatomic ion must equal the charge the ion has. So see table E. So for example, in this scenario, we're not adding up to 0. We're adding up to -2. So we know that our final answer has to be a -2. So if we look, oxygen, we know is always a -2. Chromium could have many options. If I'm looking at my periodic table, it's got 3. So let's stick with what we know first. Oxygen, 7 times -2 is -14. So something plus -14 has got to equal -2. So this number, whatever it is, it's got to be +12. +12 minus 14 is -2. So we know there. So now we just got to work back. 2 times something is +12. And chromium has the options of 2, 3, and 6. So we're going to go with the +6 option, because 2 times +6 is +12. But notice here, in a polyatomic ion, what you add up to is the charge that the ion has itself. Now, I don't expect you to be able to be a whiz on these things because of all those exceptions to the rules, but generally speaking, you should have the basic understanding of how you add the oxidation numbers to get to 0 to figure out the charge cancellation technique for the charges on the ions, or the atoms in a particular compound. There's 3 pages of practice that I'm happy to give you guidance in class on. Page 2, 3, 4, and 5. Actually, they're a little bit out of numbered, so that's not actually 4 pages to do. So thanks for watching. Have a good one.